Um, Welcome everyone. So I wish I could join in person. Unfortunately, I'm in Bangalore and a bit late here. So a virtual welcome to everyone. So I'm Johnu, a staff engineer at Nutanix. I'm co-chairing training and AutoML working group. I would like to thank other chairs as well, including Andre in the call. Yeah, so before we start, just want to show our interesting journey for the last 5 years. So I was actually part of this journey from the very start. In 2017 December, we actually had the first TensorFlow operator, which is TF job v1 alpha 1, onto Kubeflow 0.2, Katib v1 alpha 1, and a new operator, a separate operator for PyTorch. PyTorch job was added, which was again in alpha 1. Then when TF job went to alpha 2, 0.4, we actually had beta 1 version for the job operators, but still they were separate, right? In 0.6, we had the first V1 version, which was in 2020 for the TensorFlow and the PyTorch. And we had V1 alpha 2 of Katib, which is again a redesign of the initial architecture. And that's the base of the current one. In 1.2, we actually had the V1 beta 1 for Katib, which is the current API version, and we are looking forward to having V1 version in the near future. In Kubeflow 1.4, in last October 2021, we had a unified training operator, which is a single controller for all the frameworks, like a single operator which can handle a distributed training of all frameworks. And right now it's in V1, and currently we are standing at 1.6 release, which happened a month ago with lots of bug fixes and the feature enhancements. So this is our design consideration from the very start to actually have a low bar and high ceiling for all the Kubeflow components. So the low bar means we actually want to get started in a very easy manner for any user role. So particularly for a data scientist, he needn't know about the underlying Kubernetes concepts or APIs, hiding the entire infra. I'll talk about like how we are trying to solve that. From an infra engineer point of view, get minimal set of requirements, have a self-contained manifest, and make deployments easy. When we talk about high ceiling, we want to allow extensibility and customizations on top of it, right? Like for data scientists, that means he trains something locally, and then if he actually wants to get it onto the distributed world, how can he scale it, like without any extra effort? And from the infra point of view, when we have lots of these jobs in the infra, how do you better manage that, maximizing the resource utilization? So regarding training operator, where are we right now? So we have a unified operator right now for distributed training across frameworks. That includes TensorFlow, PyTorch, MPI, MXNet, and XGBoost. So having a unified operator helped us to have reduce code duplication. We have a common library which is used for the training operator, which is a separate repository in Kubeflow. And most of the features are shared across frameworks now, which is so a single feature is a consistent view for all the frameworks right now. This also leads to better stability because we could bug fix in a much more faster manner. So a single bug fix could actually fix issues all across if the features are shared. So currently we are in V1 version. And one important feature that we added very recently, right now it's in master, it's not there in 1.6 Python SDK, and it will be there in the upcoming release. And that is our first step towards easy management for data scientists. So we could run the distributed training jobs using Python SDK directly within Notebook. So I'll talk more about it. I'll show how we can do that. So there is no need to build images manually anymore. So a data scientist who is actually working on notebooks, he doesn't need to interact with kubectl or learn Kubernetes manifest how they are laid out. Instead, they could try locally. And the same thing could be actually used with a different API. They could try running the distributed version of it onto a remote cluster. Regarding the enterprise features, we have support for gang schedulers. By default, we have for Volcano. We have support for Elastic training via PyTorch, Elastic, and Horovod. Currently, training jobs can be deployed using Python SDK in a programmatic manner or the standard Kubernetes manifest. So for someone who's new here, so you see a YAML here. So for Python SDK, you don't need to worry about it. It will be automatically generated for you and submitted to the cluster. So a plain manifest would look something like this, right? Like this is a distributed TensorFlow job having 3 replicas here, 3 worker nodes, and each using 1 GPU. So this is a distributed job with each worker running 1 GPU each. And this is the same case with other frameworks as well, PyTorch, XGBoost, MXNet, MPI, etc. So this is how it looks like internally, right? We have a single training operator controller pod which is running, which you could actually set a HA on it. And if you submit, when you submit a TF job or PyTorch job or any other manifest, this will be picked up by the training operator and the corresponding actions will be taken. So this is just an example of how all reduce works here using TF job. This is supported in other frameworks as well, PyTorch and MPI as well. Basically using multiple workers and then doing all reduce on top of it. So earlier we talked about consistent training. So right now the Python SDK in the master supports a new API with which you can submit a distributed training job directly from your notebook onto your remote cluster. So the left side is what you typically do in a notebook, right? Like you have some model to be trained, you have your entire function there, and you could just call the function Python function, and you could, this basically runs your entire training within your notebook pod. Now, when you are ready, like if you actually want to run that as a distributed one using TensorFlow job or the PyTorch job, what you have to just do is you have to just use your create TF job from function and provide your Python function as an argument and give how many workers you need, etc., extra arguments towards that. And this will take care of wrapping things up and running that onto your remote cluster. So from your data scientist point of view, it's very similar. It's something like you run local training and remote training all within Notebook. So your entire thing about learning YAML and an underlying Kubernetes manifest, entire thing is hidden from a data scientist point of view. So just a brief intro on Katib for beginners here. So again, Katib is a framework agnostic autonomous component, which can be used to tune various frameworks, TensorFlow, PyTorch, MXNet, Scikit, or custom containers. It just expects a container, and it is up to the user to wrap whatever things in it. It could be also used to have optimization on for workflows, Argo workflows, or Tecton. So you could run an entire workflow in parallel and optimizing it using in Katib. So it's a scalable, fault-tolerant, and very extensible framework. You could run configurable number of parallel trials, maximum number of trials, matching your resources. I'm not getting too much into it, but you can take a look at it. Depending on your framework, this supports much tuning variables within the framework itself. So it supports various hyperparameter tuning algorithms by default, random grid Bayesian optimization, hyperband, population-based training, etc. Also, it supports way to add custom containers for your newer algorithms. So user could actually plug in a custom algorithm without even restarting the main Katib controller. So this could be added on the fly and things will work as expected. Katib also supports NAS, neural architecture search algorithms, ENAS and DARTs. It supports early stopping algorithm in order to save your extra resources if trial is not promising. Katib provides a rich Katib UI, and on top of it, like you could actually also use your Python SDK or standard Kubernetes manifest to deploy it. So extending to your earlier TF job, what we have done. So if you have a TF job as a trial template, right? So I'll just give a very brief intro what this YAML looks like. So again, this user needn't worry too much about it if someone is using Python SDK or a Katib UI. This will be automatically generated for you. So the YAML looks like this. So you have an objective function here. The objective is to maximize the objective metric name accuracy to reach the final goal of 99%. Right? You could run maximum of 3 trials in parallel, and to a total of 12 trial counts. You are using Bayesian algorithm here, and you could specify the trial spec. This specifies your custom container that you want to use and the set of parameters that you want to optimize on. So if you use the earlier TF job example, it actually had 3 replicas, each using GPUs. So if that is a trial spec which is used for optimizing your parameters in Katib, it will look something like this. So there will be 3 parallel trials, each using each having 3 workers using 1 GPU each. And that's one of the reasons that it is very scalable, right? Like if someone fails, it will automatically retry for the next one, and it will be tracked as well. So I'm not going too much into this, but just to give a very brief intro on how it works. It's a pretty complex controller which is sitting inside. So from a user point of view, it is just an experiment spec, which I have described in the previous slide. So once user submits it, the experiment controller picks it up. It talks to the internal suggestion controller to create new parameter list as suggestion based on the algorithm that is being used. Then the trial controller creates trials for each set of parameters that got generated, and metrics are generated from each container, which is recorded in metrics DB. So the experiment controller looks at the metrics, figures out if my objective metric is satisfied. If it is satisfied, the experiment is completed, else the loop continues till your maximum trials are reached. So all this happens in the backend, and user just need to provide the initial experiment spec, and things are automatically scaled up and down. So similar to the discussion that we had earlier in training operator, this also supports, Katib also supports a new API here, which is called Tune, where user could try the initial hyperparameter optimization within Notebook. And then once you are ready with it, you can submit to the Katib remote Katib controller using the Tune API. So you could just, similar to what we have discussed earlier, you have an objective function, which is a parameter to the tune function here with a set of parameters and the objective metric, the final objective metric name to be optimized here. And the other parameters could be given. Again, the data scientist, this is all done in a programmatic manner, and data scientists need to know anything about the underlying infra here. So just few glimpses of Katib UI. So from the Kubeflow dashboard, you could create new experiment. It shows how many successful trials, the number of trials which are in running state. If something got failed, that's also recorded. And for each experiment, you could see graph for different trials. What is the metric that we have got for each trial, whether it is getting converged, what are the different parameter combinations that are being used, etc. So this actually gives a single pane of your entire experiment, what it's happening in the background. And this could be actually used for tracking whether you have to have a much more scaled version or not. So just yeah, for next 5 minutes, I just want to talk about the user survey which we did. So this was done 2 weeks ago, just to get the feedback of users, how it goes and what they really want to get out of Katib and the training operator. So regarding the user roles, primarily the people who have submitted survey, they are from obviously they are the ML engineers, 63%. Few are data scientists, few are SREs, and few in ML ops side. So regarding the training operator, the deployment is primarily on cloud, almost half and half. And almost all frameworks are used, primarily being TensorFlow distributed training, followed by PyTorch and XGBoost. And MXNet and API is also used, but to a smaller quantity. So regarding the user feedback, user needs to see more examples. We will take a note on that to add more examples. We have few examples for each framework. So if you would like to see examples on a specific feature, please raise a pull request and we are happy to add that as well. And one ask from, actually it's a long-term ask from the community, is regarding the experiment tracking. How could we actually track experiments across multiple runs? So it is, we don't have a component in Kubeflow right now to do that. So yeah, either like we could actually provide examples pointing to popular open source tools like MLflow. We can take up that to provide an example there. One actually had problems with using the example, MNIST example on with KF multi-tenancy. It shouldn't happen. Happy to help. Please raise issues with that. We are happy to help with with that. And one other popular ask is better integration with KFP to have much more streamlined inputs and outputs from your job operator. And that's the same case with Katib as well. So I think in the coming release, we'll try to see what we can do there for better integration with the pipelines and how to get a better version of the training and the Katib component in pipelines. We'll look at that as well. And one critical command was actually on the complication for most of the data scientists. So here I strongly encourage users to try out our new Python SDK from master branch and provide feedback and how we can do a better job there. I hope with the new Python SDK, it will be much more helpful for data scientists, and much of the infra side issues will be hidden to the upper layer data scientists which they are using. So regarding the working group meeting, our working group roadmap, we try to get all these points, and we have just listed down all the options here, more documentation examples, better KFP integration. And the third point is UI for deployments and monitoring. So we will look at it, we will track this issue. So we initially had a very minimal UI, I think in the first 2 releases of TF job. And later we found out that it is much complex to add a UI just for that, primarily because users actually had much more customized deployment for TF job. And user could try much more variables in their pod spec. So it is kind of like impossible to list down all these parameter combinations in UI and expose it. And that was one of the reasons that we then discontinued with the UI, which we had in the very initial release. So we'll create a issue there, and then we would like to know more about what users need. Should we actually have a very minimal UI where the deployments can be monitored from UI rather than creating the TF job? That is one option that we can try. And regarding the integration with other frameworks, so we have a request for paddle, and also issue has been created for JAX once it is actually matured to have a distributed version. And we need more enhancements on the PyTorch Elastic training. particularly from the Kubernetes horizontal pod autoscaler side. And regarding Katib, again, we have almost half on cloud and on-prem deployments. Primarily, people are using, it is interesting to see that people are using Katib UI more than the kubectl. So we have to put more effort in Katib UI to expose more features, which we will get through the YAML manifest. People are using Python SDK as well for deployment. Regarding ML frameworks, almost all frameworks are used in Katib, and hyperparameter tuning, popular ones are grid random Bayesian optimization, TPE. So regarding the feature request for Katib, much more improved Katib SDK. In the UI improvements for, this is interesting to see, promoting models from Katib to Kserve through UI. It's a nice feature, but the tricky part is people might not be using all the components of Kubeflow while they are deploying Katib, right? Like they might not be using Kserve during the Katib deployment. That is a tricky part that we have to handle. We'll create an issue for that as well, and we would like to get the feedback for that. Support the adaptive successive halving algorithm. We have an issue to track that. Again, similar to the training operator, better experiment tracking. Will provide an example to support ML flow and how it looks like. This would need a push-based metric collection for Katib. We are trying to get that in the coming release. Other feature is again the better integration with Kubeflow pipelines, providing better support for Katib output and input in pipeline component. Simplify Python SDK, more examples and documentation help there. And regarding the security enhancement, this is also one of the popular ask. We will try to get that, and even Dominic raised in the last breakout session as well, to minimize the cluster roles required for Katib deployment. Right now, it is kind of like a bit more open. We'll try to narrow down the RBAC rules required for Katib. So regarding the roadmap, better integrations with Kubeflow pipelines for data passing, input and output. And one other feature that we are looking at, to have Kubeflow pipelines itself as the Katib target. So that way, when you can have a Katib experiment with Kubeflow pipelines as a trial. So you could try to optimize Kubeflow pipelines within the Katib component. Supporting newer algorithms, experiment tracking using ML flow, narrowing RBAC rules, which we have already discussed, and customizing suggestion deployment. Right now, it is kind of like certain parameters for suggestion deployments are exposed. Right now, we want to expose more options, mostly the deployment spec itself to the user, so that like they have much better control. So in the last, I just want to show the GitHub contributions that we had for last 5 years. And it is more or less consistent all across. A sudden rise during our initial B1 Alpha 2, where we actually had a bigger overhaul, but the rest of it like have a more or less consistent commits throughout. So we hope to actually have more contributor commits actually like in the coming releases as well. Thank you for all your commits. Here are some of the links that help you to get involved. Join our Slack channel, working group channel training, and the AutoML. We have a bi-weekly meetings for our working group, both which conducts for both training and the AutoML. So join the group and you'll automatically get the invite for that. So if you're using Operator or Katib, please update the adopters list in the GitHub repository. We need your help for adding more tests, documentation, and if you would like to contribute, please check developer guide, and we are happy to help. Feel free to ping us in Slack if you have any questions to get involved. And if you have submit a new proposal, if you have a feature request, and we can take it from there as well. That's all from my side. Thank you again to all of the users and the contributors especially.